It became known as the wire that won the West. Cattlemen feared it, farmers revered it. Yet it helped tame and build a nation. In 1879, barbed wire was the only product we produced. Today, we're so much more. From hot, raging steel come products that touch the lives of everyone. We're Northwestern Steel and Wire Company, and we're making it in steel for you. The Northwestern story began more than a century ago. Northwestern Barbed Wire Company, nestled in the quiet Rock River Valley near Sterling, Illinois. These men turned out 10 spools of barbed wire per day, all under the direction of company founder Washington Dillon. It was his dream to build a successful company based on hard work and innovation. At the outset, the company purchased the smooth wire it needed from an outside source. Over the next few years, production capabilities grew to more than 600 spools of wire every day. However, in 1928, disaster struck. Flames engulfed the facilities, inflicting an estimated $250,000 in damage. The company quickly turned adversity into an opportunity for growth, and construction began immediately on a new and larger facility. During the crunch of the Depression, it became increasingly difficult for Northwestern to rely on outside suppliers for smooth wire. Then company president Paul Dillon, son of the founder, realized that Northwestern had to begin melting steel and making its own rod and wire for fabrication. Recovery Act provisions limited the installation of blast furnaces, but not electric furnaces. Paul Dillon had found the solution he needed. Once thought of as too impractical to utilize on a large scale, electric furnace steel making became the backbone of growth for the company, now called Northwestern Steel and Wire Company. Today, sprawling across 4 miles of riverfront, the company is among the largest steel mills in the U.S. It enjoys an annual raw steelmaking output of over 2 million tons and employs more than 2,700 people, all working to produce the highest quality products. Products such as steel structural and bar shapes, rod and wire products such as fencing, nails, and much more. It all begins here at our on-site scrapyard. High-quality scrap steel purchased by the company is destined for meltdown into new steel. That way, yesterday's byproducts and latent energy become a resource for today. Scrap is transported by truck and rail car to Northwestern's electric furnace facility, the world's largest. The scrap is magnetically loaded into a charging bucket, and the bucket moves to one of 3 400-ton furnaces. These furnaces consume up to 120 rail cars of scrap each day. The furnace roof swings away, and the bucket empties 100 tons of scrap metal, the first of many such charges that make up a 400-ton heat. 3 massive carbon electrodes are lowered through the furnace roof and positioned above the charge. 85 million watts of electric power is activated, and the scrap is melted to a pouring temperature of 3,000 degrees Fahrenheit. Northwestern pioneered this ultra-high power method of steelmaking and has remained on the forefront of electric furnace technology since Paul Dillon defied the so-called experts a half-century ago. Once pouring temperature is reached, a sample of the molten steel is taken to the metallurgy laboratory, where it's checked for proper chemistry. Then the entire furnace is tilted on rockers to begin the tapping operation. The molten steel is poured into the waiting ladle, and the ladle moves via its 500-ton crane to the stir station. The metallurgical stir station and ladle metallurgy represent modern procedures that help guarantee the quality and consistency of Northwestern steel. Here, temperature is again monitored and appropriate ingredients added. Then the ladle is stirred by pressurized inert gas, which is injected into the steel bath. This ensures proper composition and homogeneous distribution within the ladle. The next step is casting. Northwestern's 6-strand bloom and 8-strand billet casters are the largest and most modern continuous casters in North America. The ladle of molten steel empties its contents into the caster's tundish, or steel holding trough, through a ceramic pipe. This process, known as shrouding, protects the steel from oxygen and other contaminants. The tundish funnels the hot steel into either 6 or 8 separate streams, which flow into the mold chambers. As the steel passes from the tundish to the molds, it is again shrouded. This time, instead of a ceramic pipe, a tunnel of inert gas offers protection. Each water-cooled mold forms the molten steel into either a billet, a bloom, or a beam blank. Rollers transport the newly formed steel shapes through the caster and onto a horizontal bed for torch cutting to the desired length. As you can see, the steel never stops moving, hence the name continuous casting. The newly cut semi-finished shapes are moved to a cooling bed, then individually marked for identification. After cooling, the shapes proceed either to the 12-inch mill, the 14-inch mill, or the 24-inch mill, depending on the type of product being made. Northwestern's modern 14-inch mill stretches for nearly a half-mile along the Rock River. This mill rolls blooms into standard angles, small to medium-sized structural channel, and flats. This mill also produces specialty products such as hot stock flats, destined for our cold-drawing customers. Magnetic cranes move the blooms from semi-finished storage to the reheat furnace. The steel is brought to a rolling temperature of 2,000 degrees Fahrenheit, and then one by one slid into place on the rolling line. Moving through a series of roughing stands, the bloom begins to change from its original square cross-section to the final desired shape. The steel is brought to its final dimensions through a series of computer-controlled finishing stands. The ASEA computerized speed controls make sure the steel moves smoothly from one roll stand to the next, while maintaining precise tolerances. Notice that as the steel is rolled to shape and reduced in cross-section, it moves faster and faster through the mill. By the time it reaches the last rolling stand, the steel can be moving as fast as 1,400 feet per minute. The finished shapes move to a cooling bed. Finally, they are cut to ordered length, banded, and taken to waiting transportation or the warehouse. Northwestern's 14-inch mill warehouse utilizes a modern computerized inventory control system. Each order of steel is recorded by customer, warehouse position, and destination for minimum handling and ease of shipment. It's the ultimate in efficiency. Northwestern's 24-inch mill is another testament to Northwestern innovation. From beam blanks, it produces structural steel products larger than those of the 14-inch mill. This was one of the first continuous structural mills in America, meaning that the steel flows in a continuous path from start to finish without reversing its direction. Today, it's one of the most productive and efficient structural mills in the country. The processes in the 24-inch mill are the same as the 14-inch mill. Beam blanks are loaded into the reheat furnace, brought to rolling temperature, and on signal from the operator, are dropped onto the rolling line. After passing through a series of rolling stands, the finished wide flange beam or structural channel is sawed to length, then moved continuously across the magnetic piler, where it is stacked and banded for shipment. Another Northwestern innovation is evident here: the automatic marking of each steel section by a revolving die marker that stamps the heat number, steel grade, and section size every 30 inches. It helps guarantee traceability of all steel shapes sold by Northwestern, an important quality assurance for our customers. While the 14-inch and 24-inch mills produce structurals and bars, Northwestern's 12-inch mill is dedicated to rod production. The multi-zone mill reheat furnace utilizes the billets already in storage. This computer-controlled furnace keeps the billets at a rolling temperature of more than 2,000 degrees Fahrenheit. The billets are pushed out of the furnace and onto the roll line. Here they pass through a series of roughing stands which roll the billets from an original size of over 5 inches square to a rounded rod, slightly under an inch in diameter. The next step is Northwestern's Morgan no-twist rod train, North America's fastest. It performs finishing work on the rod at speeds of up to 20,000 feet per minute, about 230 miles per hour. As it exits the train, the hot rod is coiled on a moving conveyor bed. As it moves, large overhead covers regulate airflow to cool the rod for proper tensile strength and surface quality. The rod drops from the conveyor onto an automatic coiler. A down-ender transfers the rod to C-hooks for movement to the compactors. Coils are compacted, banded, and then sent to storage or waiting transportation. These new rod coils will either be sold in the hot rolled condition to customers or will be transferred to our wire mill for subsequent processing and fabrication into wire products. And that brings us to the second chapter in the Northwestern story, the company's wire products division. The wire mill converts rod into products ranging from field fence to nails. This mill is one of North America's largest and most productive single-site wire product facilities. Rod coils from the 12-inch mill move to a new technologically advanced cleaning house. The rod is first cleansed in an acid bath which ensures complete descaling. All acid is recycled for future use, thus preserving the environment. Next, the rod is immersed in a protective hot lime solution. This neutralizes the acid and acts as a rust inhibitor and a carrier for the lubricant needed in drawing. Drawing means that the rod passes through a series of dies. This reduces the rod diameter, producing the proper wire gauge needed for further processing into specific products. Many of Northwestern's wire products require galvanizing or annealing. During galvanizing, the wire is immersed in a molten zinc bath where Northwestern's exclusive Stay Bright coating is applied. This provides extra protection against rust and weathering. Annealing is the process which determines the pliability of the wire. This is accomplished through controlled heating of the entire coil. After cooling, it's moved on to fabrication. During fabrication, the prepared wire is transformed by advanced machinery into a variety of products sold under the Sterling brand name. Here, Sterling barbed wire takes shape. And here, Sterling nails are produced at such a rate as to make this facility the largest nail-producing site in the United States. Just across the Rock River, Northwestern's Rock Falls facility supports both welded products fabrication and plastic-coated products production. In fact, Rock Falls is the largest single-site mesh-producing complex in the country. Here, lawn guard ornamental fencing fabrication begins with the complex process of weaving, forming, and welding. Colorful protection is added to many products through a tough, weather-resistant plastic coating. The result is a smooth, attractive finish that guarantees exceptional quality and long life. From raw scrap to finished steel products, quality control is vitally important to Northwestern Steel and Wire Company. This philosophy is exemplified by the advanced quality control procedures which occur throughout each of the mills. In Northwestern's modern metallurgy lab, samples from each heat of steel are analyzed for purity and precise chemistry. Along with a complete series of physical inspections of semi-finished and finished steel products, we rely heavily on statistical process control. This procedure ensures that only the highest quality products bear the Northwestern name. Coupled with strict quality control, superior customer service is an integral part of the Northwestern business philosophy. In inventory and delivery, a computerized tracking system puts the status of a customer's order at one's fingertips. Timely delivery is further ensured through our advanced computer-controlled inventory and storage systems. In addition to shipping by rail, Northwestern also operates a 48-unit truck fleet. But quality control is more than processes and machines. It's also an attitude, a desire to perform to the best of one's ability, and that spirit is present in every Northwestern employee. From the mill to the sales offices to the boardroom, better customer service is our top priority. Programs like the participative involvement and quality involvement teams facilitate good labor management relations. These teams also foster unique problem-solving abilities and help increase efficiency while lowering costs. It's people making Northwestern a stronger supplier of quality steel for years to come. And that's what makes Northwestern so very special. Northwestern steel and wire products are manufactured to serve a wide range of needs. Our quality rod, structurals, and bars aid original equipment manufacturers, fabricators, and steel service centers. Northwestern wire products help do-it-yourself homeowners, builders, and of course, American farmers. Yes, Northwestern Steel and Wire Company is in the business of helping to build America. We're proud to be a part of the American tradition of innovative, pioneering spirit. And we're especially proud to serve our customers the best way we know how. That's why we have been and will continue to be making it in steel.